Okay, so an example here of the scientific method as applied to a particular problem. So this is a news story that was earlier in this year. The Edinburgh kind of council or something like wanted to change the speed limit across Edinburgh to 20 miles an hour. Okay, and it's not massive news. It made the Edinburgh, Fife and East section of the BBC News website, which is it's not quite panorama. But the reason that I found out about it was one of the lecturers on Facebook, so I've scribbled out their name because this demonstrates that they're an idiot. So he was worried about his brother getting into work because he lives a long way away. So his moan was like moany. So this guy actually does own a Porsche, but anyway. So his 1 hour bus journey into work is now going to take an hour and a half. Okay, that was his moan. Okay, so the speed limit's been reduced from 30 miles an hour to 20 miles an hour. So he's made the assumption that that's going to make his journey half an hour longer. Okay, to do that, okay, so this is what's happening. Speed limit is changing, getting slower, and he's used a model to see what effect that will have on his journey time. And his model is speed equals distance divided by time. It's one of the most simple models in science. Okay, it's used actually quite a lot. If you're wanting to work out the stress rate on a fault, you might measure the position of how far that fault has been offset in time. Okay, and then to work out the strain rate on the Earth, you might use how far it's been displaced, and then you might use some kind of geochronology to work out time. So it's not this simple equation does crop up quite a lot in geosciences and is kind of fairly important. Okay, so he's taken that equation and he's kind of done some maths because he's not he's a smart guy, he can do maths, and he's worked around to see the time that it's going to take is the distance divided by the speed. Okay. So the old time that he would say was the distance from his house to, let's say, Drummond Street, because that's where he works, divided by the old speed, and he said that the new time, the distance is not going to change, so his house isn't moving, neither is Drummond Street, divided by the new speed. Okay, and you can do some more. You can basically think so that the distance kind of is the same in both of those equations. Okay, so the new time, okay, is just simply going to be the old time times the old speed divided by the new speed. Okay, so you don't even need to know the distance to work out how long it's going to take. So this is all stuff that he's done, basically in his head in a fit of rage while on Facebook, which is always a bad idea. Okay, so he's made a prediction. Okay, so his 1 hour journey, fancy animations, on the bus is going to take 1.5 hours. Okay, that's not an unreasonable kind of prediction using our model. Okay, so did that actually happen? So we're basically doing the same thing again. So this is the scientific method. Okay, he's identified a problem. Okay, about him going to work. He's formed a hypothesis. Okay, so he's got a model. Okay, and now what we can do is we go and make some observations, and we go and time his journey. Okay, so how much longer did it actually take? So this isn't an experiment that he did. Somebody else did this experiment, and they basically used a GPS on a bus, and they worked out how long it would have taken if the bus was limited to going 20 miles an hour. And it turns out that a 1 hour journey would only take 2 1/3 minutes longer. Okay, so it wouldn't take half an hour longer. So this is very, very wrong. Okay, so we've got a prediction and a set of observations that are very, very long. Wrong. Blah, 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 blah. Okay, so I just want you to think a little bit about what assumptions in the model that this lecturer has made are wrong. Okay, So have a think about that, and